So we've discussed that every termite species has its own weaponry to defend itself, and this weaponry is showcased in the soldier cast. Today we're going to be talking about this guy right here. While it may look like he has his jaws closed in this photo, he actually has his jaws open. This is his jaws at rest. And this is him with his jaws closed. Here's a picture showing both open and closed jaws. To further delve into this, I'm going to be using some footage from a colleague of mine. And if you're interested in termites and termite soldiers specifically from around the world, I strongly suggest you check out the link below. Now I'm going to show a video demonstrating what happened with these mandibles. I want you to pay attention to the soldier right here, while he used a stick to rile the soldier up. Now it was fast, but what exactly happened here? Here's a close-up of the action of these jaws. When the soldier bites down, the jaws become deformed. And think of the tension created in an archer's bow. Once it reaches a critical point, these jaws are going to snap and slide over each other with a snapping motion, and it creates a ballistic blow to either side of the soldier's head. Now that we know a little bit more about how this soldier's jaws work, let's take another look at that video I showed you before. And I want you to pay attention not just to this soldier, but also to this piece of dirt that's next to its head. So what exactly happened here? Well, here's a play-by-play of what we saw. This is right before the soldier snaps. The small twig is riling him up. In the next frame, the soldier is biting down. You can notice how the jaws are bent inward, and you can compare that to the other soldiers that are standing around here. The next frame, and those jaws are just about to snap, and boom. Between these last two frames, the snap actually happened, and his jaws struck that piece of dirt which clobbered the worker's head right next to him, and went flying out of the frame. And here's the worker being blown sideways. So now the worker's head is still reverberating. Meanwhile, the piece of dirt that hit the soldier has hit the side of the dish and ricocheted, and now you can see it flying through the frame here. And this is the last frame. Notice the soldier's jaws are still blurry. That's because they're still reverberating from the sudden and violent release of tension and energy. Now this action is the fastest ballistic motion ever recorded in the universe as far as we know. This is faster than a mantis shrimp, it's faster than a pistol shrimp, and it's faster than the jaws of a trapjaw ant. I absolutely love this thing, and I really wonder why this hasn't been in every nature documentary you've ever seen. Now interestingly, this design has evolved independently a few different times. And it's an example of convergent evolution. Now, convergent evolution is when similar traits arise separately in evolution. And one example is the eye. The eye has arisen at least 40 times in nature, as far as we know. And they're all similar in design in that you need to have a lens and you need to have light sensing cells, but it's actually arisen separately 40 plus different times. What we don't know. Now, even though these jaws have arisen independently, they all end up with this process in the front of their forehead. And you can see an example of that here. Now, we don't really know what that is for. If it's a structural advantage, if it's something else, we really don't have an idea. An engineer might be able to help us out with that. I have a hypothesis, and that's that these termites, remember, they live in tunnels, and so this defense is going to happen inside tunnels. So if an ant comes in a tunnel, the termite can go and stick its jaws up next to the ant and snap. If it has this process in its head and it snaps over, now it's become kind of a tripod, and this might actually be like a phragmatic defense, like you've seen in some other soldiers that are just blocking tunnels. So after this strike, it might serve as a block, keeping anything else from entering. There's also this use of insect cuticle to store kinetic energy, to store potential energy. I cannot think right now of another example of this in the insects. Most of the time they use resilin, which is sort of a fiber that is stretchy, and that's how they use their trapjaw ants close things. Grasshoppers jump really fast. That's usually what it is. But this is actually using the cuticle, the exoskeleton of the insect itself, to store up this energy. And so this might be of use in some biomimicry, perhaps. Structural or materials scientist could use.